Now let's demonstrate Boolean-based SQL injection. What does that mean? It's blind in that we see no errors to provide visual output resulting from SQL injection, and Boolean-based because we'll be using Boolean operators to verify a true or false result. For this lab, we'll be using Lesson 8 in SQLI Labs. Open your web browser and go to SQL Ilabs PHP Master, page 1, and Lesson 8. This is much like Lesson 1, where they're expecting an input to the ID parameter as a numeric value. So same as before, $ID equals 1. We see the screen "You are in." This is a positive result. It means the MySQL query worked properly on the back end. Now let's break the query. Just going to add a single quote. We get a blank screen. It doesn't explain why our query didn't work. We just know at this point that it didn't work. Let's add a Boolean logic of "and 1 equals 1. Ending with a comment. This fixes the query. Now let's change the 1 equals 1 to 1 equals 2. Blank screen. Why did this happen? Because 1 equals 2 is false. So at this point, all we have to go by is a true or false result. This is true, you are in, blank screen is false. We're going to try to guess the name of the database by using Boolean-based blind SQL injection. We already know what it is from the previous labs, security, but I'll go through the methodology as if we did not already know. To better understand what we'll be doing on the front end, let's go over some of the MySQL commands that we'll be using. Let's go to a terminal, MySQL user p use MySQL semicolon. Now the first one is length. Length will print out the amount of characters in a string measured in bytes. Let's look at a quick example. Select database. We have MySQL. Select length of the database. We get a printout of the bytes. 5 bytes. MySQL 1, 2, 3, 4, 5. 5 characters, 5 bytes. Simple enough. Now let's switch to security. Now using this database. The next function we need to learn is the substory function. This returns the specified number of characters from a particular position of a given string. Let's take a look at how that works. Select substory database, comma 1, comma 1. All right. What did this do? All it did was take the first character of the database security, which is S. It's the first position of the string. Now, for this to be useful in the Boolean-based blind SQL injection, we need to convert it to ASCII key code. Luckily, there's a MySQL function for this, ASCII. Let's take a look at how ASCII works. Select ASCII, substory database, comma 1, comma 1, and that with a semicolon. Looks like I have an error in the syntax here. Good. So printed out 115. That's the ASCII key code of the value of the S character. We can do this same thing on all positions of the string security. Now let's use this on the front end to guess the first letter of the database name. We already know that it's S, or 115 in ASCII key code, but let's pretend that we don't know. To make things easy for us, let's use Burp Suite. 97 through 121 are the ASCII key values for lowercase a through z. Instead of manually typing these in one by one, let's automate it. In case you didn't set up your proxy in the previous labs, first you need to go to Preferences, Advanced, Network, Settings, and here it is. You need the loopback address for HTTP proxy. I'm using port 9500 and got to have this check box for use proxy, server for all protocols, and the no proxy for box needs to be empty. Start up Burp Suite. Go to the Proxy tab, Options, Edit. We'll change the port to what we configured in Firefox. Make sure you have intercepting on. Now I'm going to inject this. Same thing we did in MySQL. However, instead of a number here, I have the string ASCII. You'll see why in a second. So once again, this is calculating the ASCII value of the first position in the string of the database. So go ahead and run that. We have intercept on, drop these Firefox get success doctext. Here we go. This is what we want. So send that to intruder. Go to positions, clear. We're going to highlight ASCII. This is going to be our payload position. Click payloads. We're going to use numbers, sequential. Starting number is going to be 97. Ending number is going to be 121. As I said before, this is lowercase a through z in ASCII key code. Step 1. Now just let me explain something here. This is where we're going to try 97 through 121, the ASCII position. So let's go back here. Now, before we start the attack, we need to make sure that intercepting is off. Back to the intruder, start attack. As you can see here, it's trying each payload, starting from 97. Let's take a look at the first one here. You can see here that this did not work because it's a blank screen. All right, so it's already finished, and I see the byte length from the responses. So right here is a different length than all the rest of them. It's just order by length. See, everything else is 913. We have 897 length here. So let's just check that out. Here we go. That's the positive response. You are in. Now, as we found out before, 115 is the ASCII key code for S. That's the first letter in the database name security. So based on that, we know that the first letter of the database name is security. And we can automate each position so we can find out the full name, just based on this Boolean blind SQL injection methodology. Now let's take a look at lesson 9. Same thing, input the ID as parameter with numeric value. ID equals 1, you are in. Okay, so let's try to break this query and see what happens. Nothing happened with a single quote. Let's try a double quote. Nothing. Let's try a escape character, \. Still nothing. Let's try to invalidate the ID parameter. Still nothing. So it looks like no matter what we put in, it's going to say you are in. So we have no idea whether the query is working or not. What can we do here? Throw in a sleep command. This is a time-based blind SQL injection. So let's go to MySQL and run that down. Here's a simple sleep command. Select sleep, 5 seconds. All it does is wait for 5 seconds and then continue the command. So let's apply the same methodology as before, but this time sleep if the result is true. So how do we do that? Same thing we did, adding sleep at the end. So we have select ASCII subster, select the first position of the database, which is S or 115 in ASCII key code. Then sleep if true. So let's go ahead and test that out. There we go. Sleeping for 5 seconds, then returning. So let's try an incorrect ASCII key code 114. It immediately returns null. Make sense? So if it's true, it'll wait for 5 seconds. If it's false, it'll immediately return null. Let's try this on the front end. Same thing, sleep for 5 seconds. If the ASCII key code 115 for the first position of the database is correct. See how it's timing out? It's waiting for 5 seconds, and then it returns. Same thing, incorrect results, immediate return. So let's use Burp suite and raise the sleep to 30 seconds, same thing as we did before, and see if we can automate the enumeration of the first character of the database. I'm just going to change the string to ASCII. Turn on intercepting on Burp suite. Get rid of this. Okay, here we go. So send that to intruder. Let's go to the positions tab, clear, select ASCII, same as before. Now I'm going to change the sleep from 5 to 30, just to give us a little bit more time. Same thing as before here. We have numbers, sequential from 97 to 121, step 1. Turn off the proxy interceptor and go back to intruder and start the attack. Now we can see these are being returned immediately, no sleeps. We have to watch this very closely. See, at 114, it stops. That's because it's hit the sleep command on 115. So that's the indication here that 115 is the correct value. It's just going to wait 30 seconds, then it's going to continue all the way down to 121. Done. So it's going to keep going, and we have figured out that the first value is 115, or S.